Hello friends, welcome to session 7 on projection of plane surfaces. See here there are so many problems which will be useful to you later in the later in projection of solids and isometric projections and all that. These problems are very useful to you. Understand the concepts, sir. Small variations will be there in each and every problem. You should know how exactly to manage the variations. See here, there is an hexagonal lamina of size 25 has an edge on HP. Okay, that means you take edge position. Okay, I told you for hexagonal lamina, edge position is different, corner position is different. Okay, now we are doing only edge position problems. Okay, 20 has an edge on HP and rotated about this edge till the surface of the lamina is inclined at 60 degrees to HP and the opposite edge lying in VP. Okay, see here, previously up till here we have done this. That is, in the previous problem, that is hexagonal lamina of sides 25. Okay, B dash, C dash, C dash, F dash, D dash, C dash. Okay, when you are looking from here, B is seen, A is away, B dash, C dash, C dash, F dash, D is seen, E is not seen, D dash, C dash. And this front view and this front view will remain same because you are moving it parallel to VP. That means this and this are same. This is surface inclined at 60 degrees to HP and all that. You got the top view. Once you got the top view, you know very well, out of 6 edges, AB and ED have maintained true lengths, and AF, FE, BC and CD, they have lost true length. Now in the previous problem, we had inclined, edge on HP was inclined at some degrees to VP. But in this problem, they have made a small change. That is, edge on HP, opposite edge is lying in VP. That means opposite edge is DA. Okay. See here, edge on HP, opposite edge is lying in VP means you should put DE on XY line. That means the distance in front of VP should be 0. That is, DE when it is on XY line, immediately you say DE is lying on VP. Okay. And you know already B dash, A dash and XY line means AB is on HP. AB is on HP. DE is on XY line means opposite edge. AB is HP, you know. DE is opposite edge. Opposite to AB is DE. Okay. This DE is on XY line means you should clearly say that opposite edge is lying in VP. See here, you should understand that this top view has its surface inclined at 60 degrees to HP. Now, 60 degrees to HP I am not changing. 60 degrees to HP I am not changing. Then if you rotate about, anyway AB is on HP, if you rotate the lamina in any position, as long as 60 degrees to HP is constant, the top view should remain same. Okay, I have rotated this in such a way that DE comes on XY line. DE comes on XY line. But in this problem, it is clearly, as soon as you look at that, you should tell the surface is already inclined at 60 degrees to HP. Okay, 60 degrees to HP. AB is on HP and opposite edge is lying in VP. That is how you should conclude. Okay. Now, once you do this, okay, take the projectors up. Okay, take the projectors up and get the corresponding front view. That means this is the lamina has an edge on HP, opposite edge is lying in VP, with surface inclined at 60 degrees to HP. In that condition, when you are looking from front view, that is in this direction, how it appears in the front view is this. How it appears in the top view is anyway is this. Okay. Now, to what level you should develop here is, you always look at XY line. If you look at XY line, if dashes appear on XY line, immediately you can say they are the edges lying on HP. A dash, B dash is on XY line means immediately you say AB, the edge AB is on HP. Okay. ED on XY line means immediately say ED is lying on VP. Is it okay? AB is on HP. Without dashes, if it is on XY line, they are the edges which are lying on VP. AB is on HP. ED is on VP. That means combining these two sentences, you can say that edge AB on HP, opposite edge, you see here ED, opposite edge is lying on VP with surface inclined at 60 degrees to HP, For this complex position, when you look from the front, how it appears. When you look from the top, how it appears. This top view and this top view remain same. This is second stage top view and this is third stage top view. Both will look same because the inclination to HP remains constant. Yeah, that is, the inclination to HP I'll not change. Then I'll rotate the lamina with respect to AB. Yeah, that means if it is pivoted about AB, I'll be rotating the lamina pivoting AB. That means it is AB is on HP. Keeping 60-degree constant, whatever you do, top view will not change. But in this problem, since they have given opposite edges lying in VP, I put DE on XY line. Okay. That is why the opposite edge is lying on VP. In that way, you have completed this problem. Okay. That is hexagonal lamina of size 25, edge on HP, surface inclined at 60 degrees to HP, opposite edge lying in VP. Draw projections in this position. See here, once it is in this position and all that, okay, you can see if you draw one x1 y1 and if you draw the side view of this and all that, okay, x1 y1 if you draw RPP, left view if you are looking from here, you are getting E double dash bracket A double dash, F double dash bracket C double dash, A double dash bracket B double dash here, and if you join that, it will be a line. Okay, 3 points you get, correct? No? When you're looking from here, I'll show you in the other problems, 3 points. That means when it is in this position, okay, you can say the lamina is perpendicular to RPP. It is seen as a line. When the lamina is seen as a line in any of the planes, you can immediately say it is perpendicular to that particular plane. Okay, anyway, the problem gets over here. Edge on HP, opposite edges lying in VP. Okay, now you see hexagonal lamina of size 25 has an edge on HP and rotated about this side till the surface of the lamina is inclined at 60 degrees to HP and the edge on HP also lying on VP. You see a small change again. See here, till now here we're done. Please understand, it is the same thing here. Previous problem, opposite edge was lying in VP. Now here he says, edge on HP itself is lying in VP. Okay, edge on HP itself is lying on VP. That means you have to make AB on XY line. With inclination, I don't change. And pivoted about AB, if you rotate the lamina, as long as inclination to HP is constant, the lamina top view, this top view won't change. You rotate in such a way that AB comes on XY line. But even if it comes and sits on AB on XY line, the surface inclination to HP cannot change. If the inclination changes, the top view also changes. We don't want top view to change because inclination to HP is fixed to 60 degrees to HP. Keeping 60 degrees to HP constant, you have to do. Okay, now what exactly should happen here is, if you look at this, immediately you say, AB is on HP. Same AB is lying on XY line. That means second stage top view same as third stage top view because inclination to HP is same. The top view does not change. Now AB is on HP. Same AB is on VP also. That means you can say AB is at the intersection of HP VP. That means AB is not only on HP but also on VP means it should be at the intersection of VP HP. Okay, that's the way you should conclude. Then take the projectors up and get the front view here. See here, if you look at this, AB also here, A dash B dash is also here. That means the conclusion is AB is at the intersection of HVVP, that is on XY line. Okay, that is, it is at the intersection of HVVP with surface inclined at 60 degrees to HP. Okay, now if you imagine here, a good imagination will tell you, if it is 60 degrees to HP and if it is in this position, if you are looking from left view, so let us say left, this is D double dash bracket D double dash you get here, C double dash bracket D double dash somewhere here you get, B double dash bracket A double dash you get. That means if you get a straight line here, that means it is perpendicular to RPP, but surface inclined to HP is 60 degree. Naturally, with respect x1 y1, it will be 30 degree. That means in these cases, surface inclination is 60 degrees to HP means in this position, it is 30 degrees to VP also. Anyway, we'll discuss such cases later on. Okay, this is another problem. What we have done. These are all the concepts. Please understand. Once you do second stage, top view, front view, this can be managed in any possible way. Okay. If edge on HP, opposite edge in VP means immediately put D on XY line. If edge on HP also on VP means put AB on XY line. If edge on HP parallel to VP means make AB parallel to XY line. Okay. And at the same time, if they say edge on HP is at a distance of 50 mm from VP means from 50 mm from XY line you draw this AB. That means this top view. In that way you can do any type of problems here. Okay, now you see hexagonal lamina of size 25 has its surface inclined at 60 degrees to HP with the nearest edge 10 mm from both HP VP. You see here. Now be careful. It is same as previous. Small change we have made. Same hexagonal lamina of size 25 has its surface inclined at 60 degrees to HP with the nearest edge 10 mm from both HP VP. Okay. See here. Now you see. I have drawn hexagon 25. A, B, C, D, E, F. AB 25. This is 25 plus 30 degree. 25 minus 30 degree. This is 25 plus 30. 25 minus 30. If you're doing solid edge, then you complete this. Okay, in that way. Now you see here. So far, edge used to be on HP or VP, something like that. Now edge is not on HP. But they say the nearest edge is 10 mm from both the planes. From both the planes means both from HP and VP, its distance is 10 mm. Now you see here. Now what I've done is, I've already taken 10 here. Okay, instead of writing front view on XY line, I have drawn front view at a distance of 10 mm above HP. Okay, 10 mm above HP. Okay. Now the surface is inclined at 60 degrees to HP. Now nearest edge is what? BA, B dash A dash. This is 10 mm. Okay. A, B, C, D, E, F, 60 degrees to HP. Okay, looking at front view, top view, your top view will remain same. But what you should know here is, B dash A dash is not on XY line. It is at a distance of 10 mm above XY line. Now you go to the problem. What it says is, nearest edge 10 mm from both HP, VP. Okay, nearest edge is, nowadays, nearest edge is 10 mm from HP is there, but it should be 10 mm from VP also. That means, what you do is, it should be 10 mm from both HP, VP, the nearest edge, you have to refer BA only, B dash A dash only. Okay, now AB in the top view, the top view anyway, it cannot be changed because the 60 degrees to HP are not changing. You repeat this, copy, move, copy, paste, rotate in such a way that AB is 10 mm from VP also. Did you follow? That means in this problem, if you observe, AB is 10 mm from HP. Now AB is 10 mm from VP also. The nearest edge is 10 mm from both the planes. Both HP and VP, it is 10 mm. That is why you take this and copy here, move, copy, paste, rotate in such a way, AB is 10 mm. Don't be careful. When you have made AB 10 mm, same AB should be 10 mm. The same edge should be 10 mm from both the planes, not DE. Okay, you do this way and then get the corresponding projections in the front view. Okay, this is A dash, B dash, C dash, D dash, E dash, F dash. In that way, the problem is completed in this respect. You see here, once you see the problem here, you will clearly know, okay, well, you clearly know, you draw with XY, VP, HP and all that. You draw the top view and front view at a distance of 10 mm you do, and this is 60 degree. Okay, and the person who looks at this, he will clearly understand, oh, AB is not on HP, it is 10 mm above HP, he'll know. Okay, then he'll get the top view. Keeping inclination constant, I have rotated by 90 degree so that the same AB is 10 mm from VP also. That means, looking at the problem itself, you yourself can frame the problem, that is, edge on edge, that is a hexagonal lamina of size 25, has its surface inclined at 60 degrees to HP with the nearest edge, let us say AB here, is 10 mm from both HP, VP, or 10 mm from both the planes. Okay, and now we come to the end of session 7. Thank you very much for watching. We'll continue in session 8. Okay, thanks a lot. Thank you.